Okay, IB, this is 3H bivariate data. What we're going to talk about here is using two variables instead of single variable, which is the univariate. And we're just going to check if there's a correlation. So, this seems to be something you guys have all done before. We're going to talk about this, just like the situation here with Mr. Price, who had number of past papers and their outcomes and their percentages. And he just wanted to see, is there some sort of correlation between the two? So he sits there, he graphs them, takes looks at the graph. Now remember, when we're talking about variables, we have independent variables, the ones that you control, right? And then you got dependent, the ones that are controlled by what you put in. So we don't control the dependence directly, but we do get to control what we put into it. And so basically, on a piece of paper, if you were to graph those, take a look, how closely are those two variables related? Is there a correlation? Is there not a correlation? So what would these things look like? Well, here are 6 different charts. The first chart is a positive correlation, just a correlation. It's positive because the variables, as the independent increases, so does the dependent variable. Negative, as the independent variable increases, the dependent decreases, and then something like this would just be kind of just no correlation going on at all. Now there are different types of correlation. On top of the fact that there's positive, negative, and no correlation is the fact that they can be strong, which means they're all tightly, nice, neat, straight line of points. A loosely aligned line of points is a moderate, and then a weak correlation would be just kind of they're flowing in that general direction, but nothing really overly can say, wow, that has to happen. So those are the 3 types: positive, negative, and no correlation. And then of a particular positive or negative correlation, you can have strong, moderate, or weak. So we'll skip over this. Actually, no, we'll do this one. This goes back to the very, very beginning. I kind of glazed over it a little bit and didn't talk about it. Actually, this one is different. Heights and weights of 10 camels. So we have the weight and the height, and they have the height be the independent, so it's actually reversed from what I would actually think of the x's on top. They put x's on the bottom, and the y's are on the top. So it would not matter actually which way you guys want to make that, as long as you state kind of and verify. You can see on the graphs they have height on the bottom, which would be their independent. Weight depends on their height. And so if you draw a scatter plot, what are you thinking? Okay, there's your scatter plot. I'm thinking, hey, that's definitely a positive correlation. The taller the camel is, the more weight it is. And it seemed to be fairly strong, so I would say moderate to strong. And if you look here, there appears to be a strong positive relationship. So that is what we are going to say. In example 13, we talk about the number of members and the number of pets. So each of 9 families and the number of pets they have. So how many people are in the family and how many pets. So in this particular case, they actually chose to put the number of people in their families and then the number of pets on the dependent side. So again, I don't think there's necessarily going to be a right and wrong answer to that, unless it's kind of straightforward. Some of those are not as straightforward. Number of pets and family members, they can be switched around, and I think they work just fine. Obviously, number of hours of sleep and how well you do on a test, there would definitely be a correlation that the more sleep you get, the more or the better score you would get, which would be the dependent on the sleep. So that might be a little more situational. Describe the pattern here. I still think that's a positive correlation, as you can see. I think this one might be a little bit more moderate, and it does say moderate. And then state with reason whether you think one variable causes the other. And I think, there's a correlation, but doesn't mean that that you have to. And here it says the number of members in a family is not caused by the number of pets in a family has, and vice versa. Because if you think about it, there are several in here that have 4 family members, but they also have 2 or 3 pets. So it seems like there's a general trend that the more family members you have, that then means the more pets you have, but it doesn't mean it has to be. One has to cause the other. Do I have to have family members to have a pet? Possibly not, right? Doesn't mean it causes it. Same thing here. We got another table. They got their scatter plot going across here. I would think that, hey, that's a pretty strong positive correlation. And then, does it mean that one has to imply the other? It says not really, because we're talking about the number of schools and the number of restaurants in a town. So the more schools you have, the more restaurants you have. But just because they build another school doesn't mean you're going to get another 10 restaurants or something like that. So I think that cause issue is really kind of a funny one, because one does not necessarily guarantee the other one to have to happen. So there could be a correlation, that's what we're saying, strong correlation, but it doesn't mean it has to happen. So kind of think about what the input outputs, the dependent and independent variables are. And then it says state a possible reason why the number of schools and the number of restaurants increased over a 40-year period. Well, obviously, it kind of makes sense. If you have to open up another school, that means the population in the town got bigger, so therefore you're going to need more restaurants for those people to eat at. So there could be correlations, right? The population might be a better causation than just the school. This one, table shows the temperature in degrees Celsius and the time of days taken for cream to sour. Ew. So, as you can see, I think this would be a negative correlation, possibly even a strong negative correlation, and state whether one variable causes the other. Now, this one, I think, I haven't even switched to the next slide. I'm kind of going off my intuition here. Yeah, I think time would cause cream to sour. So what do they say? I do not have that answer on here. Let me pause and get you an answer for that for sure. Right. And so in part C, does it cause the other? Well, it kind of makes sense that, as we're talking about temperature here, 25 degrees Celsius, 30 degrees Celsius, that is pretty warm, right? So, yeah, it doesn't take very long, for anything that is food to start spoiling when, you're sitting at 80 degree Fahrenheit day. So yes, I think we could say with certainty, not certainty, sorry, but a real good, strong indication that one would cause the other. The higher the temperature, the faster food spoils. And so here's your homework. 1 and the other half of 1, 2, and 3, and 4 and 5. Have a great day.